Hi everyone, my name is Matt and I would like to tell you about our work on analyzing viewpoint instabilities in vision foundation models. This is a joint project with Sheena, Masa, Varun, and Guha. Let's start with a concrete example of what we call the viewpoint instability problem. From one angle, a powerful model like CLIP correctly identifies a traffic light. From another, it confidently calls it a barbell. This is critical because CLIP is the vision backbone for countless systems in robotics and AI. An inability to recognize the same object from a different angle is fundamental safety failure, and this highlights the urgent need to measure and understand the robustness of these models. How do we formalize and measure this problem? Our core idea is straightforward. A small change in camera's viewpoint should only cause a small change in the model's feature representation. We formalize this with our instability score, which measures the average feature distance between a viewpoint and its neighbors. We then use a simple threshold on this score to classify each view as either stable or unstable. We use a two-step process to label every viewpoint. First, a threshold flags views as either stable or unstable. Then, we cluster the unstable embeddings, separating them into two types: accidental, which are geometrically ambiguous, and other, which are just rare views. On this slide, you can see visual examples of accidental and other unstable viewpoints we identified. Crucially, we find these instabilities across both synthetic and real-world datasets, highlighting the generality of this problem. This PCA visualization confirms that the model's feature space does separate our two unstable types. The other and accidental views form distinct clusters. As we will show now, these instabilities lead to significant failures in downstream applications. In zero-shot classification, we found that accidental viewpoints cause a catastrophic failure in performance. This failure extends to generative tasks like image captioning, where unstable views cause the model to hallucinate, proving the vision instability directly corrupts the language model's output. Finally, for 3D reconstruction, unstable views cause the model's geometric understanding to collapse into distorted shapes, proving the final 3D quality is directly determined by the stability of the 2D input feature. Crucially, we found that these instabilities are predictable from a single view's features. A simple SVM achieves high accuracy across both synthetic and real-world dataset, far better than random guessing. Since accidental views are fundamentally ambiguous, they can't be fixed with more data. Our two-stage method computes a reliable probability score for a view being accidental. This score allows the system to know when to distrust its own input. Our method's 92% correlation with accidental labels provides a reliable signal of ambiguity, whereas CLIP's own confidence score is completely uninformative. In conclusion, our work identifies viewpoint instability as a critical weakness of current vision foundation models. We focus on the accidental views and created a reliable method to detect them, a vital step towards building more robust and safe AI. Thank you for your time.